Thank you. I have a few slides in my presentation on caribou, and I'm beginning to think I should take them out. Because I can tell you there's a lot of people in this room that know a lot more about caribou than I did. Anyways, we do, as a society, we do quite a lot with cumulative effects every time we do a development. So we force, that's probably the right word, we force folks who are doing developments to go through and assess the cumulative effects on biodiversity. And we have done that for quite a number of years. I guess what I would like to do is explore today whether there is some alternative ways to do that process, and I'm here and I'm talking explicitly on biodiversity, some alternative things that we could do with cumulative effects that would make a little more sense, that would make it more effective for management. And I'm going to preface my presentation with saying nothing I'm going to say today is new analysis or new mapping or new anything. All I'm doing is applying existing methods to the cumulative effects question. So taking what we already know but applying it to the cumulative effects question. And go like this. I'm going to start with the example from the Shel mine. And that's not because that's a good example or a bad example, but it's kind of the status quo of where we are for doing cumulative effects assessment for biodiversity today. What we do is we map the habitats, we map what is out in the area, we then go through and sample critters in the area, throughout the area, and develop patterns, how these critters are related to the habitat that's present, and from that we produce some fairly general maps about the relative values of different habitats to biodiversity. This is a lot of work, don't get me wrong. This stuff isn't easy to do and isn't cheap. Having said that, these maps don't help managers a whole lot. They give some very general patterns about the relative values of different habitats, but it doesn't really influence management decisions a whole lot. So we spend quite a lot of resources, and we force companies, we force developers to spend a lot of resources, but I don't think it helps the actual management of those resources as much as we could. So what I'm going to talk about today is some alternative ways to do cumulative effects assessment, and I stress this is about biodiversity. So cumulative effects assessment for biodiversity. And this is a study that we started just in the last couple of years, and I'm going to talk about 2 or 3 different things. First of all, we can do some modeling of how species use the environment in a lot more detail than we presently do in cumulative effects assessment. And we can use those models to predict how things are going to respond in the environment. And we can do that at quite a wide variety of spatial scales, and I think that's important. And we can apply those models also to the future to talk about cumulative effects. So cumulative effects have occurred already. It's not like cumulative effects only occur in the future. They've already occurred in the environment, and there will be more in the future as a result of development. So we can look at a variety of different temporal and spatial scales when looking at cumulative effects. I stress that this is the end of the first year of this study, and it's a 2-year study, so I'm willing to change my mind in the next year. So if although I'm presenting some ideas today, if I change my mind, I'll change my mind. So this is preliminary thoughts. The study area that we chose to work with for this study is a couple of caribou ranges in northeastern Alberta. So it's the East Side Range and the Cold Lake Range, and that forms the boundary of the broader study area. Within that, in a nested scale, is then a watershed, which would form a just a smaller sub-study area, and then one can drill right down into things like leases inside that watershed. And this is simply meant to be an example to show how these things could be done. When choosing the things to include in biodiversity cumulative effects, as a society, we have given developers a long laundry list. And it never seems to amaze me that this list just keeps growing. We have no qualms about saying do many, 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 many things and try and do them well. But the list of things to include, to model, to evaluate cumulative effects just seems to keep growing. In our study, we chose to work with only 6 different things because we said, it's a reasonable sized study. We're going to have a couple of people working on this, but we can't work with that long laundry list. So we chose to focus with 6 things. 2 species, 2 species groups, and a couple of things that deal more with biodiversity in general. So we chose the gamut of things that are part of the laundry list, but we didn't try to tackle everything on that laundry list. Part of the desire to move ahead or to think about this question is there was a group of us that were working with the Alberta Biodiversity Monitoring Institute. We said, the data we collect as part of the ABMI, it should be able to be used to help folks do cumulative effects assessment for biodiversity. The information we collect, it wasn't collected for this purpose, but the information we have should be quite capable, should be quite effective at helping folks evaluate what are the cumulative effects of biodiversity in a particular region or sub-region or even a small area within that. So how would we use the information collected by the ABMI to help folks do a cumulative effects assessment? Some of you may not be aware or be as familiar with the ABMI, so I'm going to give 3-4 slides on just a brief overview of the ABMI. But it's brief, let me tell you, brief. In addition, the work that we're using for this project, we borrowed heavily for the analysis that we're doing on birds from the data that Aaron Bayne has collected. So it's part of the data that he uses. And I stress that this data from ABMI and the data from Aaron are an important part of what I see as an advancement in cumulative effects assessment. Because what it does is it pulls in huge amounts of data that weren't collected by the individual development. It's just as valuable data, but it's data that we as a society have already collected that we can use to do better modeling and better predictions. So the ABMI was a series of points throughout the province. The idea is to sample 1/5 of those points in 1 year, so after 5 years all the points have been sampled, and then the 6th year you start again. So the province gets sampled on a rotating interval throughout a 5-year period. In addition to sampling the grid sites, there's a lot of off-grid sites that are sampled to help fill out this evaluation of relationships, to help create or to model relationships between how species their abundance of species is expected to change as things in the environment change. The ABMI works with a variety of different critters, samples a variety of different critters. Today I'm only going to talk about information that we collected for vascular plants and birds, but the ABMI is actually broader than that. In addition, as part of the ABMI, we collect throughout Alberta wall-to-wall human footprint. So these are maps of human footprint throughout the province. And we use a bit of a low-tech technique. We hire grad students or undergrads because they're cheap. We put them in a room and let them out every now and again to have a bite of pizza and give them a computer and say, draw those human footprints. So they do it from a satellite image. But you can see human footprints pretty damn good on a satellite image. So they draw the human footprint throughout Alberta based on satellite images. And we now have a copy of that human footprint for 2007, 2010, and we're just starting to do the human footprint for 2012. In addition, then, we have information on vegetation from a map of vegetation throughout the province, fairly coarse vegetation map. but then you can overlay it with other types of vegetation information from other sources to get reasonable characterization of the vegetations throughout the province that you can then use also as part of the analysis of when doing modeling of how species change with different vegetation types and different human footprint types. At present then, in the ABMI, we've sampled about 800 sites throughout Alberta and about 150 off-grid sites. When we first started doing the ABMI, we were just going with these on-grid sites. They said, that's what you use to monitor change in the province. But to develop models, these off-grid sites are critical. We've very quickly decided we needed to spend about 20% of our effort, 25% of our effort on off-grid sites, just so we could do the modeling that was required to actually be able to detect change. So this, and it's these that facilitate using ABMI information to talk about cumulative effects. So the present project, I'm going to talk about black-throated green and caribou, and if I were doing it again, I would just delete caribou, because but anyways, I got the slides here, so I'll show you caribou, and I'll hope I don't have to answer any questions on them. And invasive plants. Not that the other three aren't important, but those are the first three that we had done, and this is the end of the first year, and so I was scrambling a bit to get pull these figures together for the presentation today. So what we do then for each species, so this is black-throated green warbler, we calculate, model relationships between human footprint and abundance of the species. And we do it for human footprint, here's an industrial or forestry or cultivation and so on. We model relationships between the species abundance and the amount of the human footprint. In addition, we can model relationships between how the species changes, the abundance of the species changes between the different vegetation types and for forests at different ages of any particular forest, how the abundance of the species change. And this is simply based on using the ABMI data plus the off-grid sites, and in birds, we have gazillions of points from Aaron's data. Those, think of them as off-grid sites, but we have 2,000 or so additional off-grid sites for birds to model these relationships. This information is quite strong. These patterns, when you have enough data, you can pull out these patterns pretty darn good. You can then create predictive relationships of how you'd expect a species, the abundance you'd expect of a species in the environment. So here for black-throated green, this is the study area. For every quarter section, based on the human footprint that's present and the vegetation that's present, you can create an expected habitat suitability for that critter. In addition, this is current. If you backfill the human footprint, so you just said, I'm going to take the human footprint and eat the vegetation in from the edges of it to backfill that human footprint, you can create a map of expected habitat suitability for black-throated green under de-footprinted conditions. All we've done is eat the human footprint in from the edges based on the surrounding vegetation. So here's current condition, there is backfill condition, and this map then simply shows the change in habitat suitability for black-throated green warbler in the study area. And I would argue, I'm going to argue, that this map is a huge step forward for managing systems. I mean, 3/4 of you guys in this room already do this for caribou. I mean, this is just how you do it. I mean, this isn't surprising, this isn't new, this isn't different. It's just how you do it. Well, it's not how we did it for cumulative effects assessment. There's no reason we can't just do this for cumulative effects assessment. Once you have a map like this, it becomes pretty obvious. Habitat suitability has gone down a lot in some of these red areas, and there's yellow areas where it hasn't changed that much at all. From a management perspective, all sorts of things start running through your head now. What can I do in these areas to manage cumulative effects? This is present cumulative effects. What can I do to manage cumulative effects in the future? And where should I try to manage those cumulative effects in this regional landscape? In addition, what this map does, the map is calculated once, but there's absolutely no reason that you can't sub-select this map and say, I'm only interested in that region. What is the cumulative effects there? Or I'm only interested in this region. What's the cumulative effects there? The map gets calculated once, but it's possible to summarize that map to talk about cumulative effects at any series of nested subregions. And that, again, I think, is a huge step forward for cumulative effects assessment. Like I said, none of this is new. All it is applying what we already know to a cumulative effects assessment and recognizing that we're going to use all the data we've got. Rather than just focusing on, we force somebody to go collect a bit of data in their area, let's take a step back and use the information we have to talk about cumulative effects assessment. I'm going to repeat this message 3 times. If you do exactly the same thing, the same message holds for caribou. This is applying the Environment Canada model for suitable and unsuitable habitat in the study area. And if this map is just based on fire, ignoring the human footprint piece, about 30% of the area is unsuitable. If you add in human footprint, most of it is unsuitable for caribou on the Environment Canada model. The Environment Canada model is only one of the models. There's a Sorensen model, and I have no doubt that everybody in this room has their own pet model. You can create this map from any model, as long as you know what the model is and as long as you have the underlying habitat and human footprint map. You can create these models and you can assess what are the cumulative effects on caribou. And it doesn't take a lot of thinking to say, you know, when I look at those maps, there's some things that jump to my mind on how to manage cumulative effects in the next step as we move into the future. This is also another piece of data that, I don't know, 6 people have already said today. You can analyze those data that you use to create the models to look to see how the species interact and change amongst them. So caribou, obviously, don't occur in many of the same places that you find wolves and deer and moose and so on. The third example I'm going to give isn't a species example, but the conclusion is very, very similar. You don't have to look at this at a species level. You can look at it at a group of species. Now I'm going to just show you weedy species, but you could choose any group you want. You do the analysis at the species level and then roll it up amongst the species. So here there's about 20 weedy species that live in that regional study area. Weeds invade, this isn't too surprising, weeds invade areas that are heavily disturbed, and as a result, the intactness, so it's a slightly different measure, it's not the abundance, but the intactness of the weedy community tends to be high in some areas, and wherever there's human footprint, the intactness of that community tends to be a lot lower. So this group map, this map of a group of species, looks and can be interpreted very, very similar to what you do for any individual species. And again, you can summarize it at any level you like. You can take the whole region, you can take a sub-region, you can take a small area. You can summarize cumulative effects at any level you like, and you can then imagine what you would do from a management perspective throughout the region to manage cumulative effects. I think it helps then quite a lot as you're looking at how would I manage cumulative effects in my region. These maps really provide a leg up, and I would suggest are a lot more effective at helping you make decisions than a broad map that says, biodiversity changes slightly between these three different habitats. These more detailed maps give you the information that you need to assess cumulative effects and to make management decisions. And you can do it for these 6 things, which we're doing in the present project, or you can do it for another 26 if you've got the time and the resources to do it for those. It really comes down to creating the models and doing the mapping. As long as you have the resources and the data to create the models and you have the underlying maps, you can do this stuff for these 6 or for any other 26 that you wish to work. So I'm going to end then just with a couple of closing thoughts. And I must admit that some of these closing thoughts might be half-baked, but they're where I'm thinking, okay? So, we can do the model. And folks have done it with caribou up the Yang-Yang. I don't know how many people in this room have modeled caribou, modeled habitat associations, and created predictive maps. You can do it for many, 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 many more species, and you can sum it up for broad groups of biodiversity. It just takes resources and time and the right brains. There is people that can do these modeling and these mapping for us. It just takes time and money. What I haven't talked about today, and what is at least as important, is creating the underlying maps to do those predictive mapping. It's pretty straightforward to create a map of today. You take a satellite image or an air photo and you draw what's there. It is less straightforward to create a map about what the habitat looked like 20 years ago, 50 years ago, or 100 years ago. And that's because this filling in from the edges works, but that's only one description of what the habitat looked like in the past, or could have looked like. There's natural disturbances, and those natural disturbances also change what the habitat could have looked like in the past. So to get a good evaluation of the change or the cumulative effects of today, one has to look at what are the range of maps that could have looked like in the past, and how does that change to what we presently have, and get some sort of an average characteristic. The same thing goes into the future. There's a lot of uncertainty about what's going to roll out on the landscape and how natural disturbances are going to roll out on that landscape. So it's actually a set of maps for the future would need to be analyzed to talk about cumulative effects in the future. So you can apply the models to maps, but creating these maps is a big issue, and it's something that we haven't tackled in this project. In addition, I would stress that these predictive maps are that. They're predictive maps. It's a bit like me predicting it's going to snow on Friday. I might be right, and it might not be. I can predict whatever I like to predict, but it's a prediction. Unless you're willing to go out and monitor and evaluate whether or not your prediction is correct, it's simply a prediction. One needs to have adaptive management. Monitoring and adaptive management so that you can tell whether your prediction is correct. You can assess whether it's correct, and you can adjust the prediction over time so you get better and better prediction. This is a critical part. Without this, it's just a bunch of guesses. This prediction part, this testing the prediction part, is a critical component of effective management. The present project only deals with number 1. That doesn't mean that these aren't important. It just means that's all we had the resources to do. Cumulative effects assessment definitely needs to do that. Definitely needs to do 2 and 3 as well. Some take-home messages, and these, I think I've already said most of them. We can do cumulative effects assessment right now. We can do it. We've got the data for many, 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 many species, and we can amalgamate those up to groups. We've got some maps already. We can make the maps better, but we can do this stuff. The critical part is, do we as a society want to find the resources to do this effectively? What we haven't thought about, I think, as much for society as we should, is when one does cumulative effects assessment, It is the same assessment for every developer in the region. It isn't different for this lease and this lease if they're in the same region. Cumulative effects assessment is a regional thing. It needs to be done at the regional level. It is an evaluation that's important, valuable to everybody throughout the region. It makes sense, and I think this would be a shift from society's standpoint, that instead of trying to task individual developers to each go and do a cumulative effects assessment, it makes a heck of a lot more sense for folks to say, this is a shared problem. We need to find a shared solution and need to resource it effectively. I think I'm done.